Good morning, students. In the previous video session, you have completed the comparison between translational motion and rotational motion. That is one of the important question you have to learn. So today we are going to have a new topic, that is rolling motion. You know, in our daily life we came across many rolling motions. You know that when you are moving in a bus, when you are moving in a car, when you are moving in a bike, its wheel rolls. So these wheel possess what are rolling motion. So like that, not only this wheel, suppose you are choosing a disc and throwing it, you can see what are rolling motion. So in our daily life, what are we came across these rolling motions. Now let us consider one object, okay? On disk you can consider like this. Consider on this, and assume that one disk is there, and this is the center of mass. Here the center of mass. Now you can choose a point P any place here. When you are choosing a point P, listen here. We are choosing a point P on this disk. What happened means this P translational motion. This is translational motion. This P is translational motion is rotate along with this center of mass, and its rotational motion, it rotate with respect to this center of mass. So two things you have to remember. One disk is there, you are choosing a point P, any place you choose. You can choose here also. It's what are? Translational motion is always along with this center of mass, and rotational motion. And rotational motion, what will happen? Rotational motion with respect to the center of mass. So there is what about rolling motion. Remember these 2 points here. That's all. Just we are choosing a point. Any point you can choose from a disk. So all the point in the disk, its translational motion is always along with the center of mass, and its rotational motion, what will happen? With respect to this center of mass, it will rotate. Wherever you choose the point, it rotates with respect to the center of mass. Next one is about the combination of translational and rotational motion. Combination of translational and rotational motion. So, as we have already seen that we have told that this translational motion and the rotational motion is included in the rolling motion. Let us see how this translational motion and the rotational motion is included in rolling. Let us see how it is happening. You see, assume that you have an object of radius r. Like this one object, its radius is r. Radius is what r. So if its radius is r means in one full rotation, what will happen? One full rotation, its circumference is what 2 pi r. Its circumference is 2 pi r. So for one full rotation, this 2 pi r is what displaced. 2 pi r means what? It's circumference of a circle. So for one full rotation, what will happen means its center of mass also displaced. You see, this is a center of mass. We can consider. We can keep it as this is a center of mass. This center of mass also displaced what are this 2 pi r times. Understand that? So if you are choosing a circle of radius r, its circumference is 2 pi r. So for one full rotation, what will happen? Its center of mass also displaced 2 pi r times. Like that, any point you choose here, all these points what are? Displaced 2 pi r times. Now, let us see. You see, this center of mass moves only in straight line path. Now it is in this position. Assume that now the radius changed. Radius is changed some other position. Still, this center of mass moves in straight line path. Radius moves another position. So for one full rotation, here in this figure just showing what are the full rotation. So during this full rotation, center of mass is what are? Moving in straight line. It shows that the center of mass always moves in straight line path. So the center of mass moves in straight line path means this center of mass is having what are? Is moving in translational motion. So that is what here center of mass takes straight line path. So it possesses what are? Translational motion. All other point in this circle, you see this point now. This point possesses two motion. One is along with the center of mass, that is what are? V, translational motion. Another one is what are? With respect to this will turn. So V, rotational, V rotational. So any point you choose, one is what are? Along with, that is what first we have seen. During rolling motion, what are? Translational motion is along with the center of mass, and rotational motion is rotational motion with respect to the center of mass. So that's what we are saying. This any point you choose, its translational motion is what are? One point its center of mass moves in straight line path, so it possesses what? Translational motion. But all other points in this having what are? Two types of motion. That is what are? Translational motion and rotational motion. So here you can write based on this VCM is equal to V translational. It means what? Center of mass always moves in straight line path. So it possesses what? Translational motion. Remaining the point in these edges, it moves like cycloid. Like a cycloid. This is a movement of this is a motion which shows the point at the edges. So remember this point. This is what here we are studying about the combination of translational and rotational motion. If you are choosing a circle or if you are choosing an object which moves, so there will be what? The center of mass always moves in straight line path, so it possesses translational motion. All other points in this object moves in two directions. What are? Translational motion as well as rotational motion. Then what are the point at the edges moves in cyclone path. cycloid path. So here it is given some diagram. You can go through that now. So now what you have to see means VCM is equal to V translational. It means the center of mass only moves in translational path. All the other point which moves into path translational and rotational. And what happened means, suppose this is the disk. This is the center of mass. This is the center of mass. Here you are choosing a point now. This is VCM. Here you are choosing a point now. V rotational. One is rotational motion and another one is what? V translational motion. It has some resultant velocity. It has some resultant velocity. This resultant velocity, this is what? It has some resultant velocity. This resultant velocity is always perpendicular to the point of contact from center of mass. You see, this resultant, this is a point of contact now, and from here, this resultant velocity is always perpendicular to. This is zero translation. Always perpendicular to the point of contact. So remember, whenever a body, an object which is in pure rolling motion, its point of contact possesses two motion. What are rotational motion and translational motion? Its resultant velocity. This is a resultant velocity. This resultant velocity is always perpendicular to the point of contact based on its center of mass. This is the center of mass. From this center of mass, the point of contact resultant velocity is perpendicular. You see, perpendicular 90 degree. That's what. This resultant velocity is 90 degree to this center of mass from the point of contact. You can choose any point of contact. Always this resultant velocity is 90 degree to the center of mass from its point of contact. So you can write before also I told the center of mass is what? Moving straight line path. So VCM equal to V translational you can write and V rotational is equal to R omega you can write. Because this R omega means what? Because at the point of contact it possesses two motion, V rotational and V translational. The V rotational formula is what? R omega, angular velocity. Omega means angular velocity and R means what? The distance. Now, you see, finally, now we are going to the conclusion part. Finally, how we can conclude this? That's what. Finally, we can conclude this. You see, when this moves from this point of contact to motion, V rotational and V translational, the magnitude of this V translational and V rotational is always equal. So, V translational is equal to V rotational. The magnitude, the size of, the value of these two, translational motion and the rotational motion is same. So you can write V translational is equal to V rotational. As already you know, V translational is equal to what? Center of mass. So is equal to, you can write center of mass. So VCM is equal to V rotation. Also you can write so what V rotation means R omega. So VCM is equal to R omega. This is what the final thing. This is our conclusion. So remember that here nothing. Just you can go through this. It's not not very important, but you can just go through this because some one-word questions I know they can from this part. So you see, this is what you can consider on a circle from this. If you are choosing a point, that point moves what two direction, translational and rotational, and the center of mass moves in straight line path. So it possesses only translational motion. So you can write now VCM is equal to P translational. Then here this diagram shows how it moves the point of contact. Finally, this is what from the point of contact moves two direction, V translational, V rotational, and the center of mass one direction, and the resultant of these two is what V we can tell. Always this V is this resultant V is what perpendicular to the center of mass based on this point of contact. So from that I can conclude this thing what V translational is equal to center of mass. It means what then you can tell that V translational is equal to V rotational. Why? Because the magnitude is always same. So V rotational is R omega, V translational is VCM. So all is same. So VCM is equal to, you can write what R omega. So based on these two cases also there, the combination of translational and rotational motion about the center of mass, and the momentary rotational motion is about the point of contact. Based on these two case also given, you can go through page number 251, this combination of translational motion, page number 251 and 253, just to go through that. Next one is about slipping and sliding. Slipping and sliding. Slipping and sliding. You know that there is slipping and sliding. Both are happening when we when we apply the sudden brake. Maybe the vehicle will accelerate or decelerate. You know, we have the experience of many times we are traveling in a car or bus or something. Many times we have the experience of applying the sudden brake. So sudden brake applying time, you know this, sometimes assume that you are moving in a road where the road is very slippery. When you are moving on a slippery road, opposite one vehicle is coming. Suddenly your driver applied brake. What will happen to your vehicle? What will happen? So what you can see is, when this person applying sudden brake on a slippery road, you can see that you can hear a sound and you can see your tire will slip and move further. Sometimes accident also occur. If it is a slippery road, applying the sudden brake, maybe the vehicle will not stop and it will go and hit on other vehicle. Why it is happening? It is what here we are going to see. So during this slipping time, this V translational is greater than V rotational motion. This is what is happening. This is the reason. This is the main reason. V translational is greater than V rotation. Or you can tell V CMV greater than RY. So listen here. This is the here the point of contact with the surface. This point of contact possesses two motion. What are translational and rotational? V rotational, V translation. And what happened means, when you apply the brake on this slippery road, this V translation is getting greater than this V rotation. So there is a resultant velocity here. There is a resultant velocity which is in the forward direction. So there is a resultant velocity in the forward direction. That's what this sliding is happening. So what happened means, then you can see after some time what it will slide and stops again. This pure rolling is happening. So how it is happening means, this direction there is a resultant velocity. So to manage this, opposite to this, there is a frictional force, coefficient of friction. Opposite to this translational motion, there is a frictional force. This frictional force is applied. This frictional force is increasing until this translational motion and the rotational motion becomes same. So this is a concept. Until this rotational motion and the translational motion becomes same, once this two magnitude is same, this vehicle is under pure rolling. So this is what we are saying, sliding. Understand that? So during sliding, translational motion is greater than what? Rotational motion. So mostly this sliding happening when the vehicle which moves on a slippery road. So why it is happening? Why it is happening? When this vehicle is entering the slippery road, while applying this sudden brake, this translational motion is increasing. This translational motion is increased than this rotational motion. So there is a resultant velocity. This resultant velocity is the reason why this sliding happens. So to manage this, what is there? Frictional force. This frictional force opposes this translational motion, and once this translational motion and the rotational motion becomes same, until that frictional force will increase, then these two become same, then it provide normal pure. Slipping. Next one is slipping. Slipping, this is sliding. This slipping time, V rotational is greater than V translation. Slipping time rotational motion is greater than translational. Now also the same thing. Assume that you are moving in a vehicle on a muddy road. Sometimes we have the experience while traveling on a muddy road. If sudden brake applied, you can see that the tire rolled. So that time it's rotational. This rotational V rotational motion is greater than translational motion. So here V rotational, this direction V, this is a point of contact, V translational, V rotational, and from this point of contact, this rotational motion is increasing. Rotational motion increasing means its velocity. Here there is a resultant velocity. Here there is a resultant velocity. Now, who will be there? A frictional force which is opposite to this. This frictional force will increase until what? These two translational and rotational motion is same and it set up what? Pure rolling. So, this we can tell backward slipping. This we can tell forward slipping. That is also another name of sliding, forward slipping. This one we can tell backward slipping. So this is what we can see in our regular life when we move on vehicle. We have the experience of traveling in slippery road and muddy road. When you are traveling on slippery road, if sudden brake applied, what is occurring? Sliding. What is the reason? Translational is greater than what? Rotational motion. So to manage this, what is be there? Frictional force. Frictional force opposes this translational motion direction and increase. Then these two will be equal. It sets up pure rolling. This we can tell what? Slipping. What? Forward slipping. The same thing here, opposite rotational is greater. Traveling on a muddy road or sudden brake applied. So here what is happening? Rotation is greater than translational motion. So here resultant velocity is this direction. So to oppose this, there will be frictional force which is opposite to this resultant velocity, and here it sets up what? Pure rolling. This is what we are saying backward slipping. Next there is a derivation, kinetic energy in pure rolling. We can find out the equation for kinetic energy. So kinetic energy in pure rolling. You all know that kinetic energy formula, kinetic energy translational motion, half. Kinetic energy formula is what? Half of v square. For translational motion, half m v square. Translational motion means what? Based on its center of mass. And rotational motion is equal to half what? Instead of I cm omega square. So omega means for angular velocity. This is what kinetic energy rotational formula and translational formula. The total kinetic energy, how you can find out? Kinetic energy translational plus kinetic energy rotational. So half m v square plus half I omega square. This we can keep it as equation 1. Now we know that moment of inertia I formula is equal to what? M k square. So I is equal to m k square. That is a moment of inertia formula. Radius of gyration. You have gone through that session. And omega formula we can find out from V is equal to R omega. V is equal to R omega. So omega is equal to what will come? VCM by R. So omega square is equal to V square by R square. Okay. Capital R we can use. So R, textbook capital R only. So R square. Now substitute this I value and the omega value in equation 1. Substitute ICM and the omega square value in equation 1. Okay. Now I am substituting these two. What will come? Kinetic energy is equal to half m v square cm plus half, instead of ICM, because we are finding these four with the center of masses reference point. Okay, we have chosen this because we are choosing center of mass as reference point. Center of mass as reference point. That's what the center of mass I choose. What mk square, moment of inertia formula. That's what we are finding. Now half mv square cm plus, instead of ICM, m k square into omega square means v square by r square. Now you see here half m v square v square. This term is common for all. So take all these outside. Half common, m common, v square common. Half of v square common. So remaining here what are? Only 1. Plus here what is remaining? Half taken, m taken. Remaining is v square taken. Remaining is k square by r square. This is the equation we got. This is a kinetic energy equation. We got what are center of mass as reference point. Now you can choose point of contact as reference point. So you can choose the formula kinetic energy is equal to half I0 omega square. Half I0 omega square. I0 means what? Moment of inertia. You have learned already parallel axis theorem. So from parallel axis theorem, I0 is equal to what? ICM plus mr square. mr square. Parallel axis theorem. ICM means what? I0 means ICM plus mr square. ICM means what? m k square. So substitute this ICM value in this equation. So I0 is equal to m k square plus m r square. So now what you have to do means, here omega is there. This you can keep equation 2. Okay. Now find out omega square. We know that VCM is equal to r omega, the same thing. So omega is equal to VCM by r. Omega square means what? V square by r square. So substitute this I0 value and omega square value in equation 1. Equation 2. Substitute I0 value and the omega square in equation 2. So what we will get? Kinetic energy is equal to half into m k square plus m r square into omega square value v square cm by r square. Now this v square is common for these two terms, so multiply inside. So kinetic energy is equal to half what m k square v square cm by r square plus half m r square v square cm by r square. This half is common for all, v square is common for all. So we have did like this, r square cancel. Now take all the common term outside. While taking all the common term outside, what will come? Half is common, m is common, v square is common. Remaining inside what are? K square by r square plus here r square cancel, half m v square taken outside, remaining 1. Rearrange and write down. Kinetic energy is equal to half m v square 1 plus k square by r square. So you see these two equation. You see. Here you can keep 2. This will keep 3. Here you put order 3 and here 2. Now when you are comparing this equation 2 and 4, you can conclude that two cases. What are the combination of translational motion and rotational motion is about the center of mass, and the momentary motion is about the point of contact. This is what our important question in this unit. You can see in page number 255, kinetic energy in pure rolling. Just you have to write the kinetic energy in translational motion and in rotational motion, then add the two, take the common term outside, or you will get an equation like this. ICM value, VCM you can find out this manner. The same way, you can choose what are. Here we have taken the center of mass as reference point, and here we have taken the point of contact as reference point. We will get the same equation and we can give that conclusion. And my dear students, today we have gone through the sliding, slipping, and the combination of translational motion, rotational motion, rolling motion, and the kinetic energy in pure rolling. From this today's session, you have to practice this derivation. It is one of the important derivation. And the definition for sliding and slipping, it is also very important 3-mark question. So you have to learn, you have to practice this. Bye bye. See you all. Thank you all.